Hello everybody, sorry for the delay today. Having a lot of issues with Word and the printout of this, but finally got it working and we're uploaded and ready to go. I wanted to go through this verbally just so I can add some comments, but for the most part I'm just going to be kind of reading the notes to you. This is called the Law of Large Numbers. Okay. Definition law of large numbers is the more attempts that are made, the closer and closer the results will get to the theoretical or actual probability of the event happening. Okay. And I tried to come up with two clean, easy examples you would understand. Flipping a coin. You know that flipping a tail is 1 out of 2 or 50%. That's called the theoretical probability. That is what is expected every time, but it's not what happens every time. If you flip a coin 10 times, that does not mean you're going to get exactly 5 heads, 5 tails. Okay. The results might be 3 tails, 7 heads, you could have 2 tails, 8 heads. You could even have 0 tails and 10 heads. You could flip 10 heads in a row, although probability tells you it's not likely, but it could. The law of large numbers says if you flip the coin 50 times, it's going to get a little closer to 25 tails, 25 heads. Still wouldn't be surprised if it's 20 tails, 30 heads, or something like that, but it's going to get closer to 25, 25. If you did it 500 times, it's going to get even closer to 250 tails, 250 heads. And if you flip it 50,000 times, now it's going to start getting really close to 250,000 tails, 250,000 heads. So the law of large numbers says the more and more attempts that is made, the closer that the result will be to the expected or theoretical probability. Same thing with rolling a die. Okay. If I want to roll a 5, you should know that it's a 1 out of 6 probability. Also 16% or 0.16 or rounded to 17%, but I'm going to focus on the 1/6. If you roll a die 6 times, does that mean you're going to get exactly 1 5? No. You may be able to roll a 5 2 or 3 times out of 6. Okay. You may get no 5s, so may not ever get a 5 if you roll it 6 times. So the fewer times you roll it, the more erratic the probability might be. However, if you rolled it 60 times, a 5 will probably happen closer to 10 times. Maybe 7 or 8, maybe 12 or 15. Okay, but real good chance it's not going to be 30 times out of 60. Okay. So the theoretical probability is 10 out of 60, which is 1/6. If I were to roll a die 6,000 times, the law of large numbers says I'm going to get close to 1,000 5s. Okay? And if I were to roll a die 600,000 times, it's going to get really close to happening 100,000 times, because 100,000 over 600,000 is 1 out of 6. Okay, the law of large numbers says the more and more and more and more and more you do something, the closer you're going to get to that probability. Okay? And then let's go to the concept of the law of large numbers. It's what makes businesses like casinos and insurance companies make money. Okay, we're going to cover insurance stuff Wednesday and Friday, but it's what gets them to stay in business, because the law of large numbers pretty much guarantees them a profit. They do not want a few customers. Okay, they have to have a lot of customers. Okay, there is no such thing as a small casino, and there's really no such thing as a small insurance company. Small casinos and small insurance companies will go out of business because they need more money or more people to get to that law of large numbers probability. Okay? I'm going to use a probability question to show you how a gambler, maybe a county fair, game of chance. I haven't been to a county fair in a long time. I know they used to do things like this sort of. And that's the probability of 2 events. I'm going to have the customer roll a die and flip a coin. And I'm going to tell them If you roll a 5 and flip a tail, it's going to cost you $1 to try. But if you can roll a 5 and flip a tail, I'll give you $10. If you can roll a 5 and flip a tail, I will give you $10 if it's successful. Now, every time you try it, you got to pay another $1. So they pay $1, they roll a die, they flip a coin. If it's a 5 and a tail, I'll give them $10. Question, is this a fair game? Meaning, are they getting an even chance to win? Okay. Well, I'm going to roll the dice. I've already lost because I didn't roll a 5 and flip a coin. That cost me $1. That cost the person $1. If they want to try it again, they got to pay another $1. Okay. I rolled a 1, flipped a coin. Obviously, it's not a 5 and a tail because this was a 1. I didn't really need to flip the coin. Okay. Question is this a fair game? Okay. That's what page 2 goes to. You have to find the actual or theoretical probability. The probability of rolling a 5 and flipping a tail is the probability of doing one times the other. So it's 1/6 times 1/2 or 1/12. The probability of that occurring is 1/12, or what I'm going to focus on is it's only going to happen 1 out of 12 times is what probability says. Okay? Okay. Probability of 1/12 means it is expected to happen one time every 12 attempts. So a fair game should be paying $12 for every successful roll and flip. Okay. This says it should be paying $12 per one, not $10 per one. So for me, as the person running the gambling event, I would expect to make about $2 per attempt in the long run. Okay? Now keep in mind, if we're talking 5 or 6 people or 20 or 30 people, that's not the case. We want to get hundreds and thousands of people, maybe in a 2-week fair. I have hundreds or thousands of people make this attempt. Okay? And that's really what the whole concept of gambling is. You know, there's always people who feel like, oh, I can definitely get a 5 and a tail, you know, before the 12th time. Okay. And if they do it after 8 times, they're in great shape. Okay. Okay. If you were to do this with a friend only 6 times, that's kind of what I'm getting at here. If you were to do it with a friend of yours and you give them 6 attempts, meaning they're going to give you $6, $1 per attempt, your friend could roll a 5 and flip a tail in any of the first 6 attempts. And you would have to pay your friend $10, and you would end up losing $4, okay? Because they did it so soon, quicker than the 1 out of 12, you would actually lose money. But that's because the law of large numbers says you need a lot of attempts to get toward that theoretical probability that sort of guarantees an eventual profit of $2 in the long run. Okay, like I said, there is no such thing as a small casino or a small gambler. Okay, you need a lot of numbers, or the law of large numbers says if you keep doing it and keep doing it and keep doing it and keep doing it, it's only going to happen 1 out of 12 times, even though you're paying $10. Yeah, you're going to pay out some $10, but in the long run, you're going to bring in more money. Okay. Your assignment. Decide if it's a fair game. I'm giving you 3 questions. You got to decide if it's a fair game. The way you decide if it's a fair game is calculate the theoretical probability of what I'm asking and use that probability to explain why it is or is not a fair game. And I'm doing it with rolling 2 dice. Either think about all the possible outcomes of rolling 2 dice or use the table that I'm providing. Okay, I gave you a table on Canvas, and I'll show you a quick little view of it right here. Ooh, where'd it go? Basically, this is an example of, you know, when you roll a dice, you could get a 1, 1. You could get a 1 on this die, a 2 on this die, a 1 on this one, a 3 on this one, a 1 on this one, a 4 on this one, okay, and so on. So these are all the possibilities there are 36 total possibilities of rolling a dice, or 2 dice, I should say. Okay, you could get a 2 on the first one and a 1 on the second one. You could get a 3 on the first one and a 1 on the second one, a 4 on the first one, a 1 on the second one, and so on. I have this table provided for you, or if you're a really good visualizer of this, you can maybe kind of visualize what's happening with that. Okay, if you have any questions, let me know. But your assignment is 3 questions at the bottom dealing with rolling 2 dice. One of them deals with rolling 2 6s. There's got to be a 6 on the first die and a 6 on the second die. Nothing else counts. What's the probability of rolling a 7? I will tell you the 7 has the highest probability of being rolled. Think about what all options could give you a 7. You got to get the probability of wanted over total. And then probability that you can roll an 11. Okay. All right. If you have any questions, email me. Thanks. Bye.